In this video, we're going to have a follow-up from our previous video on polynomial inequalities. Okay, so we're going to ask to solve this inequality when is x cubed minus 9x less than 0. We are given the graph, okay, and actually from the graph we should be able to determine the solutions. We know it intersects at negative 3, 0, and 3. And the graph clearly shows that it's below the x-axis, which is when it's less than 0, in this interval from negative infinity up to negative 3, and it can include negative 3, okay? And then also from, so it would be in union with the interval from 0 to positive 3, inclusive of both of those. Again, it's below the axis here. It's below the axis here. And that's what this is asking. Now, what about if we did not have, okay, the graph? Well, the first thing we want to do is take a look at our expression x cubed minus 9x and see, since part of it is asking us when is it equal, let's make that an equation, which now jumps out at you and says, well, that's going to factor. I'll pull out the x as common, then I have x squared minus 9, and that's set equal to 0, and then that's going to factor, the difference of squares is going to factor again, x plus 3x minus 3. Okay, and so that's going to equal 0 at x equals 0, x equals negative 3, and x equals positive 3. So part of it is already answered because part of it is wanting to know when is it equal to. Now, to find out the remaining portion of when it is less than 0, we're going to construct a number line. Now, basically, not a number line, we're going to construct a sign table, which actually starts by drawing a number line. And on that number line, we're going to identify the intercepts that are negative 3, 0, and positive 3. Now that number line has, okay, effectively divided all the numbers into 1, 2, 3, 4 intervals. Those intervals, easy enough to identify, negative infinity to negative 3, 3 to 0, negative 3 to 0, 0 to positive 3, and from 3 on out. Okay, now these intercepts, okay, come from the factors up here. So we want to list the factors from where we got those intercepts along the side over here, all right, in the same order in which the intercepts occur. So the negative 3 is an intercept resulting from the x plus 3 factor. So we're going to write that up here first, x plus 3. I mean, it's a little too close. X plus 3. Then we're going to write the factor from which we get, okay, the 0, which is x. And then lastly, the factor from which we get the x equals 3, which comes from the x minus 3 factor. Now, what we do, this is called a sign table. Sign table. And what we're going to do is we're going to check to see the positive and negative nature of each of these groups, of each of these factors in each of these intervals. So we simply take a test value within this interval. It's a wide interval from negative infinity to negative 3 rather. So why not choose negative 4? So if negative 4 is put into this factor, negative 4, when put in here, Okay, negative 4 plus 3 is negative, so it's negative. Okay, what about here? X, negative 4 goes in, that's certainly negative. What about here? Negative 4 minus 3, that's still negative, right? So, product of 1, 2, 3 negatives is negative. So that wins out because that's an interval, which is a negative interval, which means it's below the x-axis, which means, okay, it satisfies that part of the inequality. And let's go into the next region. A sample number in this region between negative 3 and 0, negative 2. Negative 2 plus 3 will turn positive. Negative 2 here is certainly negative. Negative 2 here will be negative. The product of, okay, two negatives and a positive is a positive. So that region is not going to answer this question. It will answer the question of when is it greater than 0. Okay, now we go again. In the region, the interval between 0 and 3, let's choose 2. 2 goes in. 2 plus 3 is certainly positive. 2 is positive. And 2 minus 3 still remains negative. So now the product of the signs, 2 positives and negative, is negative. We have another negative region, okay, which is assuring us that, okay, that's going to satisfy that solution to this inequality. But let's wrap this up and check this last region, okay, and see, okay. So we've got 3 to infinity, wide choice in numbers, any sampling value, 5 plus 3 is positive, 5 is certainly positive, and 5 minus 3 remains positive. So we have the product of 3 positives, which is a positive, okay. So we identified, okay, the regions where the graph is below the x-axis, right, in these two, as was established with the graph. And we also identified the regions where it is positive, okay, which is above the x-axis. So in the event that we were asked a follow-up question of when is it, okay, we could pose that question right here. When is x cubed minus 9x greater than 0? Then we can clearly see from our sign table that it is positive between negative 3 and 0, and it's also positive from 3 on out, 3 to infinity, which is in keeping with what the graph shows. Okay, so there we have the procedure for solving expressions, polynomial expressions, polynomial inequality expressions, is to factor the expression to find out where its solutions are as an equation, which is solved by factoring. Take each of those solutions, put them on a axis, an x-axis, a number line of sort, okay, which will, in this case, we have 1, 2, 3 intercepts, which will divide the entire number line into 4 distinct regions, okay. Each of those intercepts comes from a given factor, so we want to list the factors in the top to bottom order in the same way as they appear over here, going from left to right, okay. Now, okay, then we take a sample value within each of those regions, apply it to the factor there, and determine whether it's positive or negative. Then we take the product of those signs going downward, okay, and from the product of those signs we determine, okay, whether the graph will be positively graphed or negatively graphed within those regions, which will enable us to answer the question that has been posed from the beginning. And there you have